Hey class, today we're going to go over measurement part 2, and today's lesson is going to focus on the metric system and conversions that we do within the metric system. So many properties of matter are quantitative. Think of quantity. This involves numbers. Units of a quantity have to be specified, so we're going to look at different units today as well. Example, saying the length of a car is 17.5 is meaningless. Is that 17.5 centimeters because it's a toy car? Is it inches? Is it feet? Is it yards? So instead, we have the metric system that gives units. The metric system is also known as the SI system. This was developed in France during the late 18th century. And this is what most countries are going to use as their form of measurement. So there's no confusion when we're going from one country to another. Now the SI units, each of them have a specific base unit. There is 7 base units that we talk about in chemistry. However, we're only going to focus on about 5 of them. First one is mass. We have to take the mass of a sample all the time on our scales, and typically we do this in grams, but the SI unit is kilograms. We also sometimes have to measure the length, and that's in meters. Time is typically in seconds, temperature is in Kelvin, and the last one is the amount of substance, and you hit this at the end of regular chemistry, and that is the mole. We do not get to electric current or luminous intensity. Typically, sometimes those are usually talked about in physics class. Okay. Now, the SI base units are exactly what they sound like. They're a base, and you can actually build off of those bases and create something called derived units. Derived units are just a combination of base units. So for example, area is something that we'll talk about when we get to pressure. Area is just length times length, which gives me my meters squared. Volume is length times height times width. Again, we get 3 multiplications of length, we get meters cubed. Density is technically going to be mass divided by volume. So we got that base unit of mass divided by that base unit of length cubed. We'll also talk about pressure this year, and we'll learn that the SI unit is called the Pascal. And then we will also hit on energy, which its unit is joules, and we will also use kilojoules when we get to our thermochemistry unit. Now with base units, we also can attach something called prefixes. Prefixes indicate the decimal amounts or multiples of various units. Prefixes must be used with a base unit, which means you can't just write K and say, oh, I just got a kilo. A kilo what? Is it a kilogram, a kiloliter, a kilosecond? We need to specify. All of these have to go with a base unit. Typical ones that we are going to see is kilo, centi, and milli are the big ones we work with. Micro is worked a lot with in biology because you're looking at things that are smaller. But these are the big units that we tend to focus on. Notice here that capitalization matters. Mega is a capital M, while milli is a lowercase m. So milli can be paired with meter, so millimeter, milliliter. We can also do a milligram. So again, notice how they're always based with those base units, paired with those base units. So here we can convert between metric prefixes. For example, we can convert from this is a microliter to a milliliter, or we can convert from a kilopascal to the base unit of Pascal, centimeter to kilometer. And there are 2 ways that we can do this. And the first way, we're going to actually watch this little YouTube video that I usually show during chemistry. So it should look familiar. And so we are going to pick up here where it says converting units. Okay, so again, we can use those two steps, subtract exponents and then move our decimal. This is always the way that was easiest for me, but maybe it's not. So let's look at utilizing this with examples that we have in our lesson. For example, here we have 3.56 microliters. If you look at the prefix micro in your notes, that is to the -6 power. And we see that up here, micro is to the -6. Milli is to the -3rd. And so we're just going to go ahead and subtract those. -6 minus a -3rd, that gets us a difference of -3. Now we're just looking for the overall difference, so we know that's a 3. So then we have to figure out which way I'm going to move this decimal. Here we're going from a small unit to a bigger unit, which means that we want to make sure that we are moving our decimal correctly. Typically, if you see this negative, that means we're going to be moving our decimal to the left. But just to double check, here we have micro, and we want to move it back up to milli. So yes, we're going to move it back. 1, 2, 3. 0.00356. We can do the same thing on the example number 2. Kilo, if we look over here, kilo K is to the 3rd power. Oops. So to the 3rd power, +3. Pascal, it doesn't have anything in front of it. Pascal is a base unit, so that's 0. 3 minus 0 equals a difference of 3. Now, if we're at kilo, if we're at kilo and we want to get to a base unit, which is 0, a base unit is right here. So we want to move down. So what we're going to do is we're going to take this decimal and move it down or to the right. 3,450 pascals are in 3.45 kilopascal. And the last one is 1,678 centimeters to kilometers. Centimeters, if we look up here, centi is in -2, kilo is a 3. So here we have -2, and then here we have 3. So -2 minus 3 gives me a difference of -5, and we care about that 5. Again, typically when you see that negative, it means we're going to move back. So 1, 2, 3, 4, 5. 0.01678. But it should also make sense if we are going from centi, we're going to move back to kilo. So here is what we get for our answers. If you don't like this way, there is a route number 2, and that's using the conversion method. The only thing with the conversion method is that you have to remember to flip the exponent from positive back and forth to negative. And what do I mean by that? So here, if I'm starting with 3.56 microliter, and you want to cancel it, if we remember from conversions, if you want to cancel it, you got to put microliter on bottom, and you want to put milliliter on top, because that's what you're trying to get to. Now, micro, we learned, was to the -6, so we're actually going to put 10. We're going to flip that exponent. Instead of being -6, it's going to be +6. And then milli, this is typically -3. Well, instead of being -3, this is going to be 10 to the 3rd. And if you actually put this in your calculator, 3.56 times 10 to the 3rd divided by 10 to the 6th, you are going to get the same answer that we did before, 0.00356. Let's try it with the other two to make sure that they also work out. 3.45 kilopascal. Again, if we want to cancel units, they got to go on the bottom, and the unit we're trying to reach is on the top. Now remember, kilopascal is to the +3. So we want to flip that, 10 to the -3rd, and Pascal is 0, and you can't really flip a 0, so it's 10 to the 0 power, and you still get the same answer, 3,450. The last one is 1,678 centimeters, and you want to try to get to kilometers. So centimeters is going to go to the bottom, kilometers is on top. Again, centimeters is typically a -2, so we want to flip that sign and become a +2. Kilometers is typically a +3, so we're going to flip that and become a -3. And when you put this in your calculator, you still get the same answer as 0.01678. I don't care which way that you guys do, using this method or the conversion method, whichever one makes sense to you. Okay. Now, more metric system conversion practice. I want you to try to pause this video and see if you can get the following answers similar to me. If you don't, please make sure that you guys come up and ask. Okay, hopefully you guys have had time to pause this video. This one we should have gotten 5,000 milligrams. On number 2, we should have gotten 36 millimeters because we're moving our decimal 1 time. Here, we should have gotten 2.5 liters. We're moving our decimal 3 times to the left. And then over here, we should have gotten 5,600 grams. We're moving it 3 times to the right. Let me know how you guys did. If you guys have questions, please make sure that you raise your hand. Now we're going to talk about temperature, because in temperature, we're going to look at this a lot when we do thermochemistry, and it will pop back up. Temperature is the measure of the hotness or coldness of an object. By definition, temperature is a measure of the average kinetic energy. And if we don't remember what kinetic energy, this is energy of motion. We talk about kinetic energy when we talk about gases a lot. Temperature is a physical property. And one thing to know about temperature is heat is always going to flow from something that has higher temp to something that has lower temperature. Now, in scientific measurements, Celsius and Kelvin scales are the ones most often used. Fahrenheit scale is not used in scientific measurements. In fact, most of the country uses Celsius and Kelvin. We, as the United States, just still use Fahrenheit. We are a little bit behind on those times. Now, the Celsius scale is based on properties of water. For example, we should know that water freezes at 0 degrees Celsius, where it boils at 100 degrees Celsius. The Kelvin scale, though, is the most often one used specifically in chemistry. And we will specifically use the Kelvin scale a lot when we talk about gases. It is the SI unit of temperature, like we saw when we went over the 7 base units. The Kelvin scale is based on properties of gases, which is why we tend to talk about it a lot during our gas chapter. The other thing to know is that there are no negative Kelvin temperatures. The lowest you can go is absolute 0, which is 0 Kelvin. You cannot go lower than that. You cannot get a -4, you cannot get a -32. It always has to be a positive value. And one thing to know, and you will be using this a lot, is oftentimes you're going to be given degrees Celsius and you need to get it into Kelvin. The equation to do that is Kelvin equals your Celsius plus 273.15. So if you can add that 273.15, that gets you to the measurement that things need to typically be in. One thing to also know, and I am going to bring this picture back up when we talk about thermochemistry, there are some times when we're trying to find the difference in temperature, and therefore it won't matter if we're in Kelvin or Celsius. And the reason for that is because if we look at the difference between freezing and boiling, on the Kelvin scale, it's 100 degrees difference. On the Celsius, it's a 100-degree difference. So whenever it's asking us to find the change in temp or the difference in temp, typically Kelvin and Celsius can be used interchangeably because the degree difference is the same. Volume is one of those derived units that we talk about, and we define it as the amount of space an object takes up. Typically, volume is length raised to the third power, or we call this a cubic meter. However, other units for volume are going to be used in this class, specifically centimeters cubed, a liter, or a milliliter. Most often, you're going to see milliliter because that is what our graduated cylinders measure in. So milliliter is going to be the big one that you see. The other thing that I want to hit on is density. This is also a derived unit. This is the amount of mass in a unit volume of a substance. Density is a physical property, And typically we have to find density when we go through gases or any other problems. It is measured in grams per milliliter or grams per centimeter cubed. In fact, there are other units, as long as they're a unit for mass on top, whether that be grams or kilograms, and there's a unit for volume on bottom, whether that be milliliters, liters, centimeters cubed, meters cubed, it does not matter. So that is just kind of a general review of our metric system. If you have any questions, please make sure that you ask, and I hope you guys have a great day.